So I think you guys will have a lot of fun with that activity in the classroom. Actually, let me get this other little. So the next section is kind of focused on, we've laid down enough of the groundwork now on what particles are, started thinking about simple ways to measure them. The next section is going to go into a lot more detail about just how we actually do measurements of particles. So it talks about both kind of these high volume ways of doing it, these regulatory analyzers that we can use, or more light scattering devices like the air beam that exists to do measurements of particles. And there's an activity as well in this one that you can see about doing. It's never really the easiest one to do, but I can explain it to you guys. That will kind of have them set up a rudimentary kind of mass and volume measurement to get concentration of particles as well. So this is another section, especially following up on the last one. You talk about unit analysis. We get them thinking about things, cubic meters and micrograms, units like that they maybe aren't as familiar with. And we don't have super fancy balances here in the classroom, but again, maybe you guys have more scientific balances in the classroom as well that'll help get better, more accurate measurements of mass here as well, since we're talking about something so small. So at its core, this section is talking about, well, what is a concentration? How do we know how much of the particles we have, right? And so it's just mostly talking about the different ways. And the first one that it focuses on is mass over volume, right? So we have, I'm trying to think if it mentions it here. So basically just gives a little bit of history on how we can do these volume measurements, mass over volume measurements. It's not a new technology. This method's been around for 50 years. A lot of the regulatory sites have these mass over volume techniques to do it. It's a lot more accurate than something like a light scattering air beam or something like that. And so basically you've got a filter. So I guess, and it gives a little bit of a demo of the setup here. So you've got yourself a little size selecting inlet, passes over, with a pump you can pull air through over a filter. You collect a certain amount of particles over a certain amount of time. So the one I was telling you guys about with the spoke that I used in San Rafael, that one does measurements for a full 24-hour period. And it's constantly pulling a flow of about 17 liters per minute. So you're talking really high kind of volume exchange or a pass-through on the filter, and you're collecting that for a whole 24 hours. There are ways that we do regulatory measurements of PM 2.5 and PM 10 that can be measured every hour that use that exact technique, but instead of doing it for an entire 24-hour period, you're only doing it for a 1-hour period. I think those are more likely to be the ones, those BAMs, analyzers as we call them, are going to be the ones that are going to be at regulatory monitors that the APCD or AQMD would have set up throughout the state. So just at its core, it's just an inlet, a pump pulling through air into a filter, some electronics on board to do a mass measurement before and after. So I think the BAM we use is set up to do 1-hour measurements. It'll do like a zero measurement, like before it's passed any air through for a few minutes. It'll collect particles on the filter for about the next 45 minutes or something like that, and then it shuts off again at the end and it does another mass measurement as well. And so, we know the volume constantly going through, you have the mass, you can come up with the concentration. So it's doing that kind of continuously every hour. I'm not sure if there are any FEM monitors that are better than that in terms of time resolution. I know there are, not FEM, but I know that there are other analyzers that exist. Teledyne's got much faster PM monitoring that it can do, but those aren't federally approved methods yet, right?
The APCD here only uses BAMs.
Yeah. Yeah. So.
Like how much? What kind of mass do you collect in that small amount of time on?
Yeah, you're talking micrograms.
Yeah.
Yeah. So.
I mean, it's really sensitive.
Yes. Yeah. Yeah. Absolutely. And that's why I say this demo in this book gives them an idea of how you would do it, but it's not going to necessarily be something that they can easily do because the volume is or the mass is so small.
How do the refineries react to you guys?